Yes,
slideshow?
yes, I can see the slideshow.
Oh, but at the same time, can you see the Masako-san's face?
Yes.
Oh, okay. Oh, that's good.
What? Masako Sensei, maybe we can wait for the quiz for student, maybe 15 minutes, but we can start the presentation.
How are you?
Wait for the quiz for student, maybe 15 minutes, but we can start the presentation. Masako Sensei, we can wait for the quiz for student, maybe 15 minutes, but we can start the presentation.
Now your voice is unstable.
I just speak one time.
Okay.
Wah, link streaming udah dikirim ke chatting Kang Dapi. Bilih bade di-share.
Pak Yusuf panginten bilih bade di-share. Mangke dilajengkeun Kang Dapi nya kitu. Berarti kami jumlah mahasiswa sabaraha nu nembe join 73 jalmi.
Sebenarnya ya 200 dua pamilinya nu ngiringan ujian itu 208.
Oh, di nembe 74 atau nanti
Berenan 820 juga nama. Kemarin kan akan dimulai terbuka itu jadi 820 juga.
perpusna nama.
Ya biasanya mah udah banyak ini teh. Makanya saya takutnya kelas B karena saya nggak punya kontak ketua kelasnya, belum pernah ketemu, belum pernah ini.
Mahasiswa tolong informasikan untuk kelas C apa itu?
Pokoknya masing-masing kelas udah ada bagian, takutnya nggak nyampe gitu. Nanti saya di-chat ya, chat di
Nah, di jadwal reguler mah kan jam 9.20 ya sebenarnya ya.
Iya, tapi itu udah diinformasikan jam
dari GC.
Takutnya nggak nyampe ya.
Soalnya kalau kita mulai jam 9.30 nanti kasihan yang di Jepang itu kepotong istirahat gitu ya.
Kita coba dulu.
Yang kelas C itu belum ada. Oh, lagi pretest. Oke. Nanti tolong setelah pretest mungkin nanti join ke sini semuanya.
Bagi yang ingin berbicara selain co-host silakan raise hand ya.
Saya nggak akan berbicara. Kita lagi ngerjain pretest dulu, mahasiswanya baru join. Pak Saripul. Ini teh pretest dulu mereka teh ininya.
Iya. Jadi pretest dulu, setelah pretest nanti mereka mungkin join ke Zoom-nya.
Oh gitu.
Sekarang pretest dulu sampai jam 8.15, nanti jam 8.20-an lah kita mulai.
Ya, bisa takut nggak ada informasi yang nggak nyampe gitu saya sih. Oke lah kalau gitu.
Yang Pak Wawan terus ya Pak Wawan.
Pak Wawan teu acan hadir.
Tacan hadir.
Siap. Mangga host painten ku abdi dipasikeun ka Kang Dapi. Mangga Kang, live streaming tos surung oge da mangga nyangakeun. Untuk record teu acan.
Yang kelas C belum apa?
Tuh linknya udah ada di atas tuh. Linknya udah di-share.
Linknya sudah di-share di situ di setting message.
Chatroom ya.
Chatroom. Coba scroll ke atas.
Nah, di-share deh.
Aku mah nggak ada biasanya.
Ini udah nih daripada Pi nih.
Tuh di-share lagi tuh. Link aja mangga link.
Pak Wawan tacan aya wae.
Kita punya kelas CT Pak Wawan berenang. Apa lauren jadi moderator?
Tak mungkin itu sekejam itu menjadi moderator. Tidak akan mungkin sekejam itu. Tuh ada Pak Wawan.
Oh,
Saya
alhamdulillah moderator terus lengkap.
Enggak.
Kan meh muncul.
Mana Pak Wawan?
Tadi mah aya di itu. Merancang ke sini ya di.
Nah, menghilang deui.
Tacan di dia mah.
Dina partisipan teh aya nya. Mau baca.
Belum kali, bentar lagi.
Ya,
Tadi mah ngeliat di WA, aya sunat-sunat teh di Zoom.
Oh, Kang Wawan mah namina M Dias.
Hah?
Kang Wawan namina.
Oh, M Dias. Iya. Tapi dijentenkeun aya atuh mana?
Hostnya.
Host.
Ya aya tah M Dias.
Tuh biasa.
Mac host.
Belakang.
Atas jadi host enak. Aku dapat di rename weh. Wawan.
Namanya dia sih Kang Wawan. Dia mahasiswa.
Tos kan namanya terus digentos.
Alhamdulillah. Ternyata datang. Pak Wawan. Datang.
Kang Wawan ada jantan moderator.
Kope.
Enggak.
Kelas mana lu belum datang?
Wawan udah siap jadi moderator.
Ya. Kumplit
Asina.
Lagi siap-siap dulu tadi teh, udah jadi telat ya Pak Wawan ya.
Udah sih kan. Saya kelas non deh.
Saya kelas B. Wawan berarti kelas
Di
B.
Google
Gitu.
Classroom Kang Wan.
Ayah 2 sama. Tapi masuk
Iya,
ke
kelas
kelas B.
Ya 2 bener.
Saya kelas B yang saya mah.
Kelas D asana. Kelas C.
Ya kelas C itu nu disebarkeun.
Udah.
Untung eta weh nutri kaya. Kewe nyuci mah kade.
Udah. Tapi no buka kan 8 orang komen.
Lagi ngerjain pretest dulu kayaknya Pak Wawan.
Nggak tahu tah.
Mahasiswanya tadi sih bilangnya lagi ngerjain dulu pretest.
Nah, di saya emang nggak ada pretest dah.
Ayah Bapak.
Hah? Itu
Ayah pretest. Pengen tadi kelas teh nararoskeun.
Oh, belum ditaut.
enggak bener. Chan.
Nya da kedah ditautkeun ku Kang Wawan eta mah.
Ya, ada
Cerita kuno sanes.
Kirang update Kang Wawan mah aduh. Bahaya ya kada dieu. Kada diingetan wae.
Salah teh aya moderatorna di dieu.
Bener sih ante kelas ini mah. Yang susulan gitu.
Kang Pikit acan kanomeran, Kang.
Ya, udah jadi pelarian.
Eta ayah Vicky Wicaksono.
Siap.
Kamerana nah Kang Pikit ditutup.
Tas kan. Nah, di luhur.
Itu mahasiswanya angkatan berapa?
2018 2017
Semester 7 ya.
Tapi tanya ke
2017.
mahasiswa yang sama angkatan.
Eta linknya mana, Pi?
Ayo dina WA lah.
Anjir. Kecok.
Share di Kang Wawan. Serang share di Kang Wawan.
Itu bener.
Biar muncul.
Terus lumayan ada 84.
Mulainya jam 8.20 wae kan?
Mungkin orang terus ini mahasiswa tuh.
Mohon. Terus mulai
Mulai nambihan sih. Mulainya orang.
Dapat terusan namanya UI pretest pinten.
Nambihan sore nama langsung. Lumayan. Menuju beberes bumi ya punten bocor di.
Sarihul-san.
Yes.
So I start? I start?
Maybe 3 minutes.
3 minutes.
Yeah, okay, we will wait 3 minutes.
Yeah.
In 20.
Yeah.
Kang Devi? Kang?
Kumaha Kang?
Nah, Kang moderatorna atau kumaha?
Akan
Hah?
akan heula tapi mah nuju ieu oge SPB di dieu punten.
Siapa tuh, Mangga? Atau apa Wawan?
Ya, panginten Pak Wawan kami siap.
Oh, siap.
Hadapi. Arif.
Ya, tenang kawan. Kang Epul, Kang Arif, Kang Davi, saya mun teu tiasa sadana Kang Wawan.
Di kawitan wae kitu nya, Kang.
Jadi anu pretes nembe 130-an jami, tapi badai ditutup ya pas 8.20.
Anu kelasnya panginten Kang telat.
Tiasa janten.
Mohon. Pertos nama ya. Oke lah, dimulai aja lah, mungkin saru hawatos ininya.
Mohon waktos. Ya biasa iman ku dapi nu ngayeukeun dina teh.
Mangga. Terus dimulai aja. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Masako Sensei, we can start now. I will introduce first to our student, and then after that you can start your presentation. Okay, good morning everyone. Selamat pagi semuanya. Today we have a presentation from Dr. Masako Akutsu. She is a lecturer from the Shinshu University at Department of Agriculture and Life Science, Faculty of Agriculture. For her lecture will be conducted 3 weeks, maybe for this week and next 2 weeks every Monday. And then the topic for today about the hydroponic cultivation system. But for the next 2 weeks, for the plant factory in indoor and outdoor plant factory. Untuk mahasiswa nanti tolong kalian perhatikan untuk materinya. Nanti di akhir perkuliahan akan kita lakukan post test ya. Jadi kalau misalkan kalian ada yang ingin ditanyakan, silakan raise hand. Atau misalkan kalian tulis di message-nya atau langsung nanti kalau misalkan mau ditanyakan silakan. Nanti kita bukakan untuk mic-nya dan kalian untuk komunikasi untuk berbahasa Inggrisnya. Oke. Untuk mempersingkat waktu mungkin nanti Dr. Masako akan mempresentasikannya selama kurang lebih 1,5 jam. Oke. Masako Sensei, maybe you can your presentation about 1.5 hours until 9:40, I think. Yes.
Yeah.
Yes. Okay, maybe you can start your presentation. Thank you very much.
Yeah. Selamat pagi. Nice to meet you. I am Masako Akutsu. I belong to Shinshu University, Faculty of Agriculture from this April. So Japan is also affected by coronavirus. So all classes and lectures were by internet during spring session. I think Umum is the same. But now we can give classes less than 100 students by face-to-face offline lecture. Especially the place of Faculty of Agriculture is pretty countryside, so most students can enter and come to university without international students because they could not enter to Japan. Maybe same. So of course they and we are always wearing surgical mask. So can you see, can you hear my voice?
Yes, I can hear.
So next. So at first I will, can you see next slide? No,
Not yet.
not yet.
Yes, this is the first slide.
Oh, why? I don't know why.
Maybe you can open your PowerPoint.
Yeah. Oh, I don't know why. なんでかな。ちょっと待って。Wait. Can you?
Yes.
Can you? Next slide.
Yes.
At first, I will explain about Shinshu University. So, can you see?
Yes, I can see.
So, Shinshu University is Nagano Prefecture here. Here is famous for apples, grapes, lettuce, buckwheat, and local vegetables. Nagano is almost center of Japan. So between Nagoya is Aichi Prefecture and Tokyo. Do you know Tokyo? So Nagano is surrounded by high mountains, unfortunately without sea and ocean. Nowadays we can see beautiful autumn leaves. Shinshu University has here 5 campuses in 4 towns: Matsumoto, Nagano, Ueda, Ina. So Faculty of Agriculture is in an area. So Ina campus altitude is 770 meters, so quite high place. So here will be 2 cars in the winter, according to students, because I came here this April, so I don't know the winter. But unfortunately, here is too little snow. I like snow, but here is quite little snow. Sorry. So this is in a campus. So the campus is surrounded by forests and fields, also fields. So I think similar to Umpat. Sorry. なんでいかない So, here, this one. Total main campus of Faculty of Agriculture is total 53 hectares. So you can see palm is 21 hectares and forest is 15 hectares. So here is just only for one faculty. I think it is big, huge in Japan. So our faculty has 2 stations, Nishikoma Station and Nobeyama Station. So you can see there are high altitude. So some lecturers and some students are doing research about the plant cultivation affects high altitude. I have never been there. By coronavirus, I cannot go anywhere, even now. So, and our faculty has Bachelor, Master, and Doctoral course. I belong to Department of Agriculture and Life Science and Plant Science and Resources Division. So for I'm really nervous for undergraduate students and Bioscience Division and Biological and Agricultural Science for graduate students. My laboratory name is Horticulture Laboratory. Now I have 5 undergraduate students in my laboratory. They are researching about plant cultivation in greenhouse and field. For example, one 4th grade student compared the cultivation environment. He grew okra and moroheya. Moroheya is Jewish mallow in high temperature greenhouse. So maximum temperature is 15.5 degrees and normal temperature greenhouse. We opened side window and doors. That greenhouse maximum temperature is about 45 degrees and in the field. So in the field, maximum temperature is around 35 degrees. Now we are writing manuscript about these results. And another students are comparing the effects of compost chicken and beef, and no compost for some brassica plants. And then I will explain about my specialty a little bit. So first is for pollen preservation. Oh, no. Wait. Difficult. Coming. The slide is for beta guards. I also have experience and some papers for watermelon. And I'm trying to store the strawberry pollen here. So in Japan, beta guards are going the southern area. So especially Okinawa is the most famous area to produce beta guard in Japan. You might know Okinawa is subtropical area. This is only Okinawa, Japan. But even in subtropical areas, Okinawa, during January and February, Okinawa become a little bit cold. So beta guard cannot produce the pollen. And then 30 or 50 days after this period, yields and production of beta guards will be decreased. Most farmers of beta guards cannot decrease their incomes. Of course, beta guards will be expensive, so we cannot buy it easily. So I thought to preserve the beta guard pollen without organic solvent. So this is the method of pollen preservation. At first, I collected the beta guard flowers in the morning and removed the pollen from the anthers. After packaging the pollen by the medical paper, they were packaging the plastic bags by vacuum packaging machine like this in central picture and a vacuum condition. After that, I stored them at minus 25 degree in the freezer. After preservation for more than 1 year, I confirmed pouring fertility by crossing the real flowers and counting the pollen germination rate on the pollen germination medium. They set fruits, so it was confirmed that the Bidang pollen stored under vacuum at minus 25 degree more than 1 year had fertility. Oh, wait, what's happened? Oh, coming. I checked percent germination of pollen stored under vacuum or with air at 4 degree and minus 25 degree for 35 days. I can check pollen germination on medium with 14% sucrose, 0.1% boric acid, and 1.5% agar for bitter gourds and watermelon. As a control, pollen put at 25 degree with air, pollen fertility in 7 days. 7 days. Oh, winter was coming. Under control, condition becomes 0% compared to control condition when pollen was stored 4 degree. This one and this one, this one, this one and this one. So pollen put at 25 degree with air, this one, for 35 days, it was also died. But when pollen was stored under vacuum, or with air, this one, and this one, for 35 days, pollen fertility was more than 30%. So next slide is about difference of plant growth in growth chamber. This is cross-type plant factory. I compare the difference of plant growth by fluorescent lamp and LED for lettuce. When we glue the lettuce under fluorescent lamp, you can see the violet. Can you see? Violet spots, I think, but under pink LED, no, not pink LED, it is mixed red and blue LED. You cannot see violet spots. Violet spots is anthocyanin. So when you glue lettuce under LED, the content of anthocyanin might be decreased. It means lettuce grown under LED is less bitter than lettuce under fluorescent lamp. So compared to fluorescent lamp, LED lettuce is not bitter. Oh, coming. So next slide is, oh, sorry. Next slide is about difference of plant growth in growth chamber by fluorescent lamp and LED for factory. I compare the difference of plant growth of fluorescent lamp and LED like before slide. At that time, Left factory was grown on the fluorescent lamp. Light is on the LED. You can see that the lettuce grown on the LED has thinner leaves, little bit thinner and stem than the lettuce grown on the fluorescent lamp. Therefore, if you change the light source from fluorescent lamp to LED, the morphology of the plant will change. So be careful to change the light source. So, no, not coming. Next slide is about difference of plant growth by LED wavelengths for bell pepper. I grew the bell pepper on the blue LED. No, not coming. Oh, sorry, not. This one is blue. So wavelength is 460 nanometer. So red is 630 nanometer coming. So this one is mixed red and blue LED. So you can see the leaf number. So under red LED is the most leaves. So you can see the leaf number, the different. So you need to know where the characteristic of plants by kind of light source to prepare to the actual cultivation. And my other specialties are plant tissue culture, transformation, cultivation in the greenhouse and field. So from next slide, I will explain about hydroponics. Coming, hydroponics. Sorry, sorry. Sometimes. Okay, coming. So, do you know hydroponics? So no response. Hydroponics can the liquid fertilizer infuse nutrients necessary for plant growth. And then plants are cultivated with or without medium, so no soil condition. So hydroponics should be no soil condition. But it depends on situation. Sometimes we will use soil, but hydroponics should not use soil. So you will use medium instead of soil. So you know, kind of nutrients when we cultivate plants depends on kind of plants. So it becomes easy to make cultivation environment of especially root area to grow. But on the other hand, facility of hydroponics are expensive, so we need to think if its system will induce or not. So hydroponic system is expensive. As advances of hydroponic cultivation, one fast grow, two uniform grow, three high efficiency of fertilizer and water utilization. I think you can imagine that we can take suitable amounts and kinds of nutrients easy to plants using hydroponic system. So plants cultivated by hydroponic system can grow fast and uniform. And it is possible to reduce the amount of nutrients not used by plants to the utmost limit, which is good for the environment and cost reduction for farmers. So next is for no soil. So 5 is avoid continuous cropping hazard. 6, omit soil cultivation work. Especially in greenhouse, we have continuous cropping hazard and salt accumulation when we use soil and medium, but we do not now think about them when using hydroponics. Wait. So, not coming. Oh. Next is 7, simultaneous irrigation and fertilization in the liquid supply. 8, labor reduction. 9, work in a clean environment. So hydroponic system is easy to introduce or automation system, and it is not necessary to weed the field and greenhouse because of no weeds. So some people and then 9, work in a clean environment. I can understand, but some people think that soil is dirty. So for hydroponic system, best point, advanced point, in some textbook, work in a clean environment. On the other hand, this average of hydroponic cultivation, why? One high equipment cost, 2, need knowledge of plant physiology and plant nutrients. 3, trouble such as power outage. 4, supernumerary symptom of deficiency with inappropriate, sorry, my English is poor, nutrient solution. If hydroponic system is given power outage, all system will be stopped. In particular, oxygen does not go to the root, which may cause root rot and die. And if you fail to give the correct amount and kinds of nutrients components to plants, they might also die. So we need the knowledge of plant physiology and nutrients. And root temperature is susceptible to air temperature, so we need to keep the good air temperature. Oh, coming. Sorry. Why? Sometimes I have happened. Whoa, wait. So sometimes I have happened. The second is the second. So this one is kind of hydroponics. Hydroponics is cultivation method to grow roots in or on the surface of the cultivation and culture solution. So I will explain about kinds of hydroponic the next. The first one, first one is for deep flow technique. So we call DFT. You can see the cultivation beds. There is full of nutrient solution, and air stone is here. Is also there to avoid root rot. Oxygen goes to plant roots by air pumping all days. The nutrient solution that has passed through the cultivation bed is collected in a nutrient solution tank, added with reduced nutrients and sent to the cultivation bed again. At the time, used nutrient solution is measured pH and or EC meter. DFT is no medium or losing nutrient solution, nutrients, water, and oxygen from hydroponics. No. Sorry. So the second is nutrient flow technique. We call NFT. The cultivation beds. Sorry, point is not coming. Sometimes coming. The cultivation bed is installed at an angle, like that. The nutrient solution is only around the root tip, like that. Like this picture, air stone is in tank here. The nutrient solution that has passed through the cultivation beds drain, collected in a tank, added the reduced nutrients and sent to cultivation bed again. This is the same to DFT system. NFT is also non-medium, roots in or on the surface of culture solution, nutrients and water from nutrient solution. So oxygen is from air. So next. The third one is capillary hydroponic system. So its system is a seed that does not allow roots to pass through, but allows water to pass through on the nutrient solution. Point is not coming. Coming. Nutrient on the nutrient solution. Since the amount of nutrient solution required for this system is smaller than that for NFT and DFT, the size of the tank may be smaller than NFT. I think you can imagine it. It is no medium, roots on the surface of a seed and in the air, like that. Nutrients and water is from nutrient solution. and oxygen is also from air. So from next slide, it is a photograph the actual cultivation site by capillary hydroponic system. This one. You can see the here cultivation bed. So covered silver plastic sheet. On the silver plastic sheet, you can see the irrigation tube, like this one, black one, and this side is also irrigation tube is here. On silver plastic sheet and irrigation tube, it is put another sheet. So this sheet is does not allow roots to pass through, but allows water to pass through. This one. Can you see the nutrient solution seeping out, white sheet, like that. This is tomato seedlings. You can see the tomato roots on the white sheet. That's not allow roots to pass through, but allows water to pass through. You can see that the roots are spreading on the seed like that. The fourth one is the spray triage method. This is quite rare. Its system is continuous or intermittent spraying of nutrient solution on roots in mist form from here, like that. Its system, I think you can imagine it. This system is quite expensive, so I told you it is rare to use the cultivation. It is also no medium or roots in mist. Nutrients and water are from nutrient solution, and oxygen is from air. And next one is hydroponics with solid medium. This is cultivation method using soil medium instead of soil that supports root. At first, I will explain about kind of medium to use this system. One is inorganic medium, sand, rock, wood, perlite, etc. So this is rock wood, this is perlite. Do you know it? And another one is organic medium, coconut husk, peat moss bark. This is peat moss. So the nutrient solution and the medium contains the nutrient solution is adjusted from pH 5.5 to 6.5. So is it necessary all medium is adjusted around pH 7. It is easier to adjust the pH after adding the nutrient. So you need to adjust not you. Medium makers should be adjusted around pH 7. So this is the most important things, important points. So, and you know, the nutrient solution, I told you the medium containing the nutrient solution is adjusted from pH 5.5 to 6.5, which is suitable for plant cultivation. This is because most of the fertilizer components are dissolved in a weakly acidic environment. So this picture is hydroponics with soil medium. Left is pot type. Right is using medium box. You can buy this medium box. This picture is in the Netherlands. Is it with medium? All roots are in medium, like that. And nutrients and water from nutrient solution. Oxygen is from air in medium. Like soil cultivation. So next is benefit of hydroponics. This is advanced, little bit same. First one is automation of work and management by introducing IT technology, reduction of work labor and time by labor saving. 2, improvement of working posture. You can imagine if you raise the cultivation beds, high positions cultivation bed, you will not have to cloth for harvesting. Next one is 3, scale expansion and corporate management using employment labor. 4, maintaining a clean working environment. Next one is easy to secure workers. 6, avoiding soil diseases and continuous cropping hazard. Since there is no injury by continuous cropping, the cultivation in the field and greenhouse, because it's easy to cultivation management. 7, reduction of soil reduction is soil disinfectant. 8, introduction of environment-friendly cultivation system by efficiency use of water and fertilizer. This is already explained in advance of hydroponics, but it is possible to reduce the amount of nutrients not used by plants to the utmost limit, which is good for the environment and cost reduction for farmers. And then 9, control of growth by controlling the root environment and productive improvement by comprehensive control of above ground and underground parts. It is also easier to give suitable nutrient component compared to soil cultivation. 10, increase sale due to extended cropping period and increased number of cultivated plants. Next one is high quality and value addition of products. So this one, I will explain my final slide again. And then this one, this advantage of hydroponic cultivation. First one, the scale of cultivation of one facility is small, and each facility is not concentrated in one place in Japan. So equipment costs are too high, in which one farmer to bear to investment high initial equipment. You saw above slides. It is necessary cultivation with hydroponic system, blah blah blah. So it will be expensive. So investment high initial cost, initial in equipment and cost. I think you can imagine it. 3. Next one, limited number of crops that can be cultivated. Because there are few varieties for hydroponics, it is necessary to consider the optimum hydroponic condition. Depends on plants and plant varieties. So limited number of crops that can be cultivated. So next one is it is necessary to scale a large amount of relatively good quality water and stably throughout the year. Next one, when illness occurs, it spreads in a short period of time. Depending on the cultivation method, leafy vegetables are generally soft and have a light taste. Of course, if you do not like bitter leaf vegetables, it is no problem. So this is stable temperature control for hydroponics. Stable temperature is 15 to 20 degrees. If it was low liquid temperature, it occurs inhibition of resorption of nitrogen, phosphorus, and potassium. So opposite, if it was high liquid temperature, it occurs reduced dissolved oxygen in nutrient solution. If root respiration rate increase exponentially with increasing temperature, increase oxygen consumption. After that, decrease saturated dissolved oxygen. And then oxygen deficiency in root, the final necrosis from the tip of the root. So we need to think about suitable temperature, so we need to keep it. So securing low water for hydroponics. So I will explain about kinds of low water. At first, tap water. It has difference in water quality depending on the water in tank. In Japan, tap water is expensive. I'm not sure in Indonesia, tap water is also expensive or not. So second one, river water. It has a large variation in the amount of and composition over the years. So if you will use the river water, it is necessary to analyze regular water quality several times. This is the different. This next one is groundwater. It has difference in water quality depending on the water in tank. For example, if there is near sea or ocean, groundwater is including salt compared not near sea or ocean. And it is stable temperature over season. So we will use groundwater for hydroponics. And the groundwater is residual chlorine may react with NH4 plus to produce harmful substances in plants. Next one is rainwater. This is relatively good quality. So for rainwater in Japan, we collect it like that. Rainwater collected in greenhouse gutters is stored in tank here and used as raw water. Of course, we will use this one, just irrigation water. Next is suitable water for raw water. Of course, it should be no any pathogen, no concentration of organic substance such as suspended matter and microorganisms. No muddy, the same. This is same, sorry. No muddy, no harmful substances, and little fluctuation in water quality. If the raw water is contamination, the diseases will soon occur and the plant will grow poorly or die. So it is important good water as a raw water. So it is one of the most important to select the good raw water to do hydroponic cultivation. Of course, I think it is the same to soil condition and soil cultivation. So next is about raw water quality environment methods. If the water has excess salt, harmful microorganisms, floating materials and dust, and abnormal pH, which should be distillation, dialysis, filtration, neutralization. Before we will use water as a low water. But it is important to use as clean low water as possible because they cost a lot of money. So next one is amount of raw water. For example, you will cultivate tomato in fine weather. One tomato plant absorbs 2 liters of nutrient solution per 1 day. I think like human. So if you will cultivate 2,400 tomato plants per 10 hours, water is necessary more than 4.8 ton per 1 day. So this is in Japan. I think in Indonesia, more than 4.8 ton water nutrient solution. So it is necessary to prepare for water supplies, stoppage or shortage by tanks. So next is for condition of good nutrient solution. It should contain all the essential elements for crop growth and in the form of ions that are easily absorbed by the roots. Each iron concentration should be the total iron concentration are appropriate. And can you remember in hydroponics, DFT and MFT, oxygen required for root respiration is also dissolved. Substance harmful to crops are not dissolved. So pH is stable. pH should be stable around 5.5 to 6.5. The next one can be made using inexpensive fertilizer salt. Of course, in Japan, we can buy fertilizer, expensive fertilizer, but for farmers are using inexpensive fertilizer salt. Even if cultivation is continued, each iron concentration, ratio, and pH do not fluctuate significantly. This is a very important thing. So we need to check pH and EC for nutrient solution once or twice, sometimes 3 times a day at least. So this is last slide. This is about nutrient solution management for high quality products. Since the rhizosphere is isolated, plant quality can be controlled by nutrient solution management. It is easy to improve quality while maintaining normal growth. For example, for example, if you want to cultivate to the plants with high sugar contents of tomato, we will increase the culture solution concentration or we will add salt or seawater to the nutrient solution. So if you did increase the osmotic pressure of nutrient solution, suppressions water absorption of plants, and increase the concentration of fluids. So, water absorption for the amount of photosynthesis performed by tomatoes reduce and the taste of fruit will enhance. In Japan, you can eat sweet tomatoes that cultivated by these methods. Of course, most Japanese tomato varieties and cultivars are sweet. Therefore, there is a method, one of the methods to produce the tomato with high sugar content. So these are for nutrient solution. I explain about nutrient solution, but I like to cultivate vegetables in the field or greenhouse, and I think that the taste of vegetables cultivated in the soil are strong taste, stronger than vegetables in hydroponic system. I think if you have a chance to cultivate hydroponics, please eat them. Thank you for your attention. The class is finished. Sorry, my English is poor and I have some slide trouble. Thank you so much.
Okay, thank you very much, Dr. Masako, for your presentation.
First, sorry.
For the hydroponic cultivation system that can be adopt this technology in our in here maybe. Well, for the next, we can ask our student, maybe they have any question. Please raise your hand. Kepada mahasiswa yang ingin bertanya, silakan raise hand. Silakan. Ataupun kepada dosen mata kuliah or to the lecture. Okay, Muhammad Maksum, Muhammad Maksum, please your Pak Dapi mungkin Maksum akan bertanya. Please.
Okay, thank you. Hello, Masako Sensei. I'm Muhammad Maksum. I have 3 questions. The first one, I was wondering about the advantages of hydroponic cultivation, especially about uniform growth and fast growth. I think we can do it too in conventional agriculture. So is there any specific difference between hydroponic and conventional agriculture using soil as the medium in uniform growth and fast growth?
So when we will use hydroponic system, so cultivation environment is perfect, should be perfect. So temperature, humidity, CO2, everything is perfect. This is different in the field, and especially in the greenhouse. No, we will, sorry, when we will cultivate the plants in the greenhouse with hydroponic environment, plant growth environment is a perfect compared to normal cultivation with soil in greenhouse. And nutrient is the nutrient components are also correct. No, and without pathogen or like that. So this is, I think this is the reason to first and uniform theory we can get it. I think. Is it okay? Sorry, my English is poor.
Okay, so it's about the microclimate and perfect maintaining to maintain the environment of hydroponic. Okay. And the second one is why is coconut husk chosen as hydroponic medium? Isn't it too easy to be infected by plant disease? I mean, it's a good medium for plant disease too.
Sorry, the hydroponic husk, this one. I think this one. Not coming. Wait. Sorry. Not coming. So when we not we medium maker are making organic medium according to medium maker, like coconut husk is quite stable to adjust pH 7. So medium company and maker want to use coconut husk. But this is not, I'm not sure, but coconut medium company told me like that. So, not. Maybe your question is different. Sorry.
Okay. So after the coconut husk is still okay to be a medium for plant.
Yeah.
Okay, and the last one, kind of water that can be chosen to be hydroponic irrigation is rainwater, right?
Low water?
Rainwater.
Rainwater. So maybe in Indonesia it is good to use rainwater, but in Japan has 4 seasons. Indonesia has rain season and maybe dry season. So we don't have enough rainwater, so we cannot use. We use, but we use groundwater with rainwater. Not enough. Rainwater is not enough as a raw water for hydroponic. This is the reason. But in Indonesia, if it is possible to keep rainwater, maybe rainwater is also good.
Okay. Because I've read that rainwater has low pH between 0.41 until 6, if I'm not mistaken. So That's why I ask you, is it still okay for plant and
Yeah,
nutrition
this is
absorption?
also same, but sometimes groundwater is the same problem. So low pH, like pH 6 or not less than 6, around 6. This is we will use. We will adjust the pH 7. After that, we will add the nutrient components.
Oh, okay. So we have to add something
Yeah.
to adjust the pH into neutral.
Yeah.
Okay. Thank you, Sensei.
Okay. Okay, thank you very much.
Yeah.
Thank you.
Thank you very much, Masum, for your question. Next, maybe this is from the chat from Hisham. He asked about could you mention type of the vegetable that usually used for the hydroponic cultivation system in Japan? This is from the chat, maybe Sensei. Could you mention the type of the vegetable that usually used for the hydroponic cultivation in Japan? Maybe you can. This is from Agita Kartika. And then from Hisham.
Yeah.
Is hydroponic really environmentally sustainable system, especially with its long-term durability?
Saru-san?
Yes, Sensei.
So I cannot get your voice. No.
Okay.
So,
Maybe from Diva Hisham, the question is the hydroponic really an environmental sustainable system, especially with its long-term durability? You can see in the chat. And then from Agita Kartika. Agita, yes, from Agita Kartika. This is, I have a question. Could you mention a type of vegetable that usually used for hydroponic cultivation?
Hydroponic system.
Yeah.
So in Japan, tomato, leaf vegetables, almost tomato and leaf vegetables, but in the Netherlands, bell peppers, cucumber, tomato, so many kinds of plants are growing. But Japanese cultivars are not suitable for hydroponic system. So some researchers are searching and developing a new cultivars for hydroponic.
Okay. This is another student. Maybe you can, for the student, can you raise hand? Maybe you can ask directly because I have to scroll the question. Bayu Pradana. Silakan yuk, ada tanyakan. Silakan langsung aja. Please first raise your hand, and this is from Bayu.
Jadi unmute ya.
Mau di unmute?
Good
Silakan.
morning, everybody. Thank you for the opportunity, sir. First of all, I would like to say that this is wonderful, like Masako. But I have a question. It was mentioned that the root disadvantages from a higher root.
Sorry, voice is unstable, so I can't get it.
It's unstable. Maybe this is from the Bayu. From Bayu, the question is the last chat. Why? What is the relationship between temperature, air temperature, and between temperature and root growth? And also, why the root temperature of hydroponic plant are easily affected by air temperature?
Because its nutrient solution is water, so compared to soil, water temperature is changed by air temperature. I took a mistake for your question.
No, that is a really clear answer, sir. And if I may, only one more. What is the relation between root growth and temperature, if you may, sir?
Humidity and so this means suitable temperature and humidity. Sorry, your question is suitable temperature and humidity to grow plants.
Yes, Miss, my question is, what is the relationship between temperature and root growth? Yeah, that's the question.
Yeah. So temperature and for suitable temperature and humidity are the almost same growing in the field or in hydroponics. Temperature depends on plants, but for Japanese cultivars, suitable temperature is around 25 degrees, and humidity is 70% to 8% is suitable. Is it
okay for you? Okay. For the next question from Nur Fitria, she asked about the capillary hydroponic cultivation system. She asked about what the kind of the material that used for the capillary hydroponic system.
Capillary. So what kind of plants for capillary hydroponic system is right? What kind of plants? Sorry, I could not.
What kind of the material that you use? Yes,
material.
Yes.
I don't. I sorry. I will. Wait.
Using the capillary
yeah. I know, but I don't know the English. Sorry. No woven. Polyester. polyester, no woven fabric.
Oh, polyester.
Mm.
Okay. And then what is the kind of the
What is kind of? Hmm? Sorry, I cannot hear your voice.
what kind of the plant that you're using for the capillary? Yes.
Capillary. I have seen tomato plants. Only tomato. Now, in Japan, only tomato. I saw the capillary hydroponic system because you maybe not maybe tomato is wait. When when we cultivate the tomato, I think in Indonesia it's the same. Before harvesting, we will control the amount of water because of tomato should be sweeter. So before harvesting tomato, we will decrease the amount of water. So it is easy to control the water contents using capillary hydroponic system. So some tomato farmers in Japan are using capillary hydroponic system. Sorry.
Okay, thank you. Like, time is now is over, I think. 40. I would like to thank to you for your presentation. This is very information for our student. And also maybe for the next week, maybe yes, next week you can presentation again for plant factory indoor and outdoor. Dan untuk mahasiswa mungkin nanti 2 minggu ke depan kita akan ketemu lagi untuk 2 materi lagi, plant factory untuk yang indoor dan outdoor. Kemudian nanti dimohon kalian setelah acara ini kalian isi untuk post test ya, untuk post test nanti pengisian dari mulai jam 9.50 sampai jam 10:10. Okay, Masako Sensei, thank you very much for your presentation.
Sorry, my English is so poor.
Yes, but I understand for your presentation. Maybe we can meet again for with the same time, and also in this maybe for another lecture, maybe you can ask something. Pak Wawan, Bu Mira, Pak Arif, Kang Dapi, Pak Vicky.
Or you can, if you have a question, please send me the email.
Yes, okay. Maybe if we have a question, we will send you email. Okay, thank you very much for your today. We meet again next week. Terima kasih kepada mahasiswa untuk hari ini. Kita ketemu lagi minggu depan. Tolong diisi untuk post testnya. Masako Sensei, thank you very much.
Thank
you, Sensei.
Yeah, thank you.
Thank you very much.
Thank you very much.
ありがとうございました。
ありがとうございました。
Thank you, see you.
そう。
また明日ね。
close.
Di close, Kang.